Okay, Lamai, come on. We can do the recording, starting the session now. It is about Newton's laws of motion. Before going for Newton's laws of motion, I would like to ask you some questions. So, remember certain condition like moving vehicle. Okay. So, all of a sudden, this vehicle instantly may come to stop by a kind of like a technical fault or something. Now you want to push it for the push start. It is considered like it is not a auto gear thing. It is like a manual gear thing. You want to push it forward and then start. That's what you are going to do. So in that such a condition like that, even if you all run over, then you have to push it. Somehow you and your friend and one or two friends just join together and push it forward. At the beginning, I'm asking in the beginning, is that easy to push this forward? Push a vehicle forward if you have ever done that. Is that easy to do the initial motion? No, actually it is very hard. Actually, it is very hard. Why am I telling like that? The reason is that is the nature. Forget about it. Forget about all of this. So, how about for me, not for everybody. There are many people they can sleep at any time they want. But for me, it is hard to start sleep. It is very hard. I normally sleep around 2 o'clock, 3 o'clock in the morning. So it is not an easy thing for me to sleep. If the condition is really not nice, I can't sleep at all. Forget about it. Normally, for me, I'm telling it myself, it is very difficult to me to sleep. Then more difficult thing is, it is better to stay awake all night rather than awaking in the morning time. That is the condition for me. උදේම නැගිටිනවට වඩා ලේසි රෑ එළි වෙනකන් ඇහැරලා ඉන්න එක. So that is my condition. So there are different people in the world. For my case, it is very difficult to sleep, but even difficult to wake up. Now for that vehicle, you are trying to push it forward, right? Push it forward. It's difficult to push at the beginning. Then somehow you pushed it. Now the vehicle is in a motion. You want to stop it. Now you run faster than the vehicle and try to stop. Will it get stopped? I see at about 3 o'clock, 1 o'clock, sometimes you are online. I have seen several times. Not several times, all the days I'm like that. Okay. So during that time, only I make these tubes. So that is why my tubes have a really high quality content. Why? I have really brutal ability than many other teachers. What is that? Can stay awake for very long hours. Okay. So that is one of my ability. With no health issue even. Then the problem is, now right. Okay. Now if you are trying to stop the vehicle, you just move. Forget about that type of complicated thing. When you just put certain vehicle in a bike in a main stand, bike wheel, everybody has done it. Even for a foot cycle or motorbike, when it is parked, you just try to rotate this wheel just by moving it like this. Everybody, even girls, boys, everybody. Then the wheel just keep rotating. Then you try to stop it by just grabbing it by your hand. Even for a foot cycle wheel, even it is hard to stop. Motorcycle wheel will be very hard to stop. Haven't you ever done that? කරලා නැද්ද? Actually, for an object, it is hard to give initial motion as well as hard to stop a moving object. Good example is a moving cricket ball coming to your face. Then it hits your face and come to stop. Yes, it doesn't easily come to stop. It will fracture your bone, your skin, and many more. You might be ended up as a dead person even. Why? It is hard to stop a moving object. You will see how hard it is to stop if you hold a cricket ball for the first time, real cricket ball, it's coming towards you, your palm might get cracked. Because why? It is hard to give initial motion to an object as well as stop a moving object as well. Understand that? Okay. Right. So Isaac Newton also a person who used to see these scenarios. He has seen it is very difficult to start giving a motion to an object. It is hard to stop an object. And if you are a person running forward like this, if a person is a very light person, you can just give a side shot and he will just change the direction and move to other side. Like that. If the person is a very heavy one, you try to push him, he just look at you and just keep running. But he's a heavy person. You can't just move him. You can't stop him at all. You can't just push him aside even. Why? He's a heavy guy. Now you understood one thing. The weight also does matter in these cases. You can easily move a tennis ball. You can easily stop the tennis ball. But for leather ball, real cricket ball, it is hard to give initial motion as well as hard to stop the initial motion. Then you understood something. Mass is directly related in these cases. Okay, process that in your head, and I will too. I'm recording this in the device. I can't remember whether I pinned it. Just give me 1 second. Okay, I have pinned it. Okay, have a good look at now. So it is kind of like hard to what stop. So these conditions, Isaac Newton is a scientist. He also realized there is certain physical relationship, mathematical relationship in these cases. He studied many of these cases and formulated Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. So people used to say it like this: Newton's first law, Newton's second law, Newton's third law. Newton has introduced thousands of laws. He is father of what? Classical physics. He has touched everywhere. In the modern physics, Einstein and other people. But classical physics, classical one, completely Newton. Without Newton, no classical physics. So Newton's laws of motion, you have to say. Newton's law, first law of motion. Newton, second law of motion. Newton's third law of motion. Okay. Now write. If you write a very big topic like Newton's laws of motion, now write after that. Sir Isaac Newton studied. Sir Isaac Newton studied the nature of moving objects, nature of moving objects. So he formulated certain mathematical and physical conditions of moving objects. Mathematical and physical conditions of moving objects. Mathematical and physical conditions of moving objects. Write in a new line. He basically stated three basic properties of motion. Three basic properties of motion. Three basic properties of motion. Okay. Write the first one, Newton's first law of motion. Newton's first law of motion. Okay. Now I'm going to draw an object which is staying rest on a table. Staying rest on a table. This is what the object is. It is in rest on a table. Okay, staying rest on a table. Rest on a table. Right. Now, how about if I start to mark the forces? I didn't teach you free body diagram, but I gave you some introduction about it. I told you, when you draw certain free body diagram, you can draw the force of weight, mg, weight applying from the center of gravity. In the next week, I will teach you definitely the free body diagrams. Now, there is a force applying from the bottom of the table, because I didn't teach you the free body diagram properly yet, because you have to know Newton's third law to understand free body diagram properly. That's why I'm waiting until Newton's second law to teach. Now it is a reaction force. Reaction force applied. You should understand one thing: if it is resting in there, imagine it's like a very big kind of like heavy metal piece of metal. If the table is not strong enough, what would happen to this one? This will get instantly broken. See that? It will definitely get broken. The reason is why you have to provide exactly similar force upward to hold this. Okay. I can keep this marker pen rest on my palm. Why? Because this has a weight. That's why it's moving downward. See, when I drop, it moves down. Right? But if I keep on my palm, you can see it is happily resting on. Why? There is the weight actually applying downward, but my palm provides upward force, that is the reaction force. It is balanced. Right. Now try to consider On the table, there are very small people on it, like those blue smurfs, very small guys. They try to pull this, but it doesn't move. Why? When you apply a force, you should accelerate it towards you. You should drag it. But it doesn't move. It happens to us even when we are trying to pull a very heavy table. Heavy tables like those very archigate table and a buruta kandak. It is like a very heavy kind of like what? Heavy old furnitures, very heavy. You are trying to. It doesn't. Why? Your force is not enough. Then your brother or somebody comes and try to push it. It's still not. Your force is not enough. Then your mom comes. The mom also helped joining you and it instantly began to drag. Then mom says, that is not the reason. Due to providing the force, unfortunately, you couldn't exceed something. In the 2 weeks later from here, we are going to learn that. That is in detail. That is called frictional force. The frictional force, you were just about to overcome friction. When your mother joins, all three together could exceed limiting friction you have learned in your O-level. I am going to remind it. I am going to remind in my class even. So these forces are in balance. That is why this is not in the motion. This is not in the motion because these three forces are in horizontally. I told you, you have to consider Newton's laws of motion always along a certain direction. Sometimes it can be completely valid for vertical. Meanwhile, it is not equilibrium in horizontal. You will get to know that, but I'm telling you. Sometimes horizontally completely balanced, but vertically in a motion. It is weird, ne? Let me explain to you with examples. Okay. Now in this condition, vertically it is balanced. Horizontally, it is also balanced. In this condition, it is not moving at all. Okay, now imagine a condition. You are in a long drive. I consider yourself as a really good, well-mannered people. You are still underage, you are not driving. So it is moving, your vehicle is just moving at a constant velocity, constant. It is like your dad is the driver now. He is driving it at about 40 kilometers, 80 kilometers per hour. Is that like, but dad says, no, this is enough. All the time in a straight road, but he is still driving at 80 kilometers per hour. You might think in the speedometer still read 80, 80, 80 all the time 80. But you might think, engine is still running. Engine provides some force. But why doesn't it get accelerated? It has a forward force, and the tires and air resistance both air resistance opposing, friction opposing. These two forces are acting against. This is the driving force. Engine provides the driving force. Air resistance and friction provide force to opposing it. But you think, oh my God, why engine provides force? Why it is still moving in uniform velocity? The reason is it is also under Newton's first law of motion. Why? Forward force, when the forward force is exactly equals to friction force and air resistance, it is no longer going to accelerate further. So you might have experienced it. The car or motorcycle or motorcycle, whatever, is not going to get that limiting speed of 80 kilometers per hour instantly. It started from 0, it increased like 5, 10, 20, 40, 50, 60, 70, and then 80. Until to 80, it was just increasing speed. At 80, it is no longer. Why? The frictional thing has a uniform value. Imagine this one provide 5,000 Newton. Okay, I give you a value like 5,000 Newton. Car engine provide 5,000 Newton forward driving force, and the friction gives you about 3,000 Newton, 2,000 Newton constant resistive force. Now I want to ask you one thing. Basically, you can experience this when you are riding a bike. Normally, than a car, if it is a sunroof car, you can experience. Somehow, when you are riding, at what time you experience the wind hitting your face, more uncomfortable on your face, driving you slowly or faster? You experience when driving faster, you experience a certain wind coming against you. When you just see, you can't see any wind, trees are not moving, but you experience a constant high wind. Why? Because you are moving faster. The still air you experience like a wind against you. When you ride faster and faster, the wind hitting you, it create a force on your face, force getting higher and higher. This force is not a constant one. When you move faster, it increase more. Once it reach to, what is the difference? Now the difference is 3,000 Newton. 3,000 Newton. Once you reach to certain speed that the wind gives you 3,000 Newton opposing force, what happened? Then 2,000 to back, 3,000 to back, altogether it is 5,000, and the forward force is also 5,000. Now these three forces are in a balanced situation. Do you understand? Okay. Now have a really good look at when you are in a balanced position, only you can see it is balanced. This is balanced. Both conditions, forces are balanced. There is no unbalanced force. Can you understand? So in stationary condition, like keeping a book on a table, now actually calculator is on a book, but this is a stationary condition, it is balanced. But when that driving the car in a uniform velocity, forward force and all backward forces balance, but the thing is in the motion. Car is moving, car is not to stop, car is moving with like 80 kilometers per hour. Car is in a motion. But the problem is, car provides certain force and the resistive forces are also equal, then forces are balanced. So that is why it is moving under uniform velocity. Do you understand? In both conditions, forces are balanced. Do you understand it? Okay. Now let's write the Newton's first law of motion. Now write subtopic Newton's first law of motion. Okay, Newton's first law of motion. Now write definition. You have to write the definition symbol. It is like a hashtag or dollar sign, whatever certain important symbol for it. Okay. Now write when there is no external and unbalanced when there is no external and unbalanced force, apply on an object, the object remains stationary. The object remains stationary or moving at constant velocity. Constant velocity. I am going to say that again. When there is no external and unbalanced force, apply on an object, the object remains stationary or moving at constant velocity. Okay, this is what the definition. Okay, Ramai. Now copy these two diagrams. And now first write this one as examples. Write examples. No need to draw these horizontal forces. Now write it like this. A resting book on a table. Resting book on a table. First example. Resting book on a table. So the condition is resultant force is equal to 0. That means 0 equals to mg minus r. So this is the condition. R equals to mg. Resultant force should be 0 to have it in a Newton's first law condition. That means there should not be any resultant force. Resultant force is 0. 0 equals to mg is the downward and other force is upward. You have to subtract it, and R is equals to mg. Now write in the next one. Let's write the values even for the next one. Example number 2. A moving car under uniform velocity. Example number 2. Moving car under uniform velocity. Moving car under uniform velocity. Okay. Let's write some mathematical things and everything in a sentence. As an example, a car is running at a constant velocity of 80 kilometers per hour. 80 kilometers per hour. At this moment, the car engine provides the effective driving force. Car engine provides at this moment. Car engine provides effective driving force of 5,000 Newton. Effective driving force of 5,000 Newton. in the forward direction. Now, right. And the friction is some 2000 Newton. Meanwhile, the air resistance is 3000 Newton. 3000 Newton. Let's consider the forward force. Forward force. What is the forward force? If forward is driving force, I write like driving force is what? 5000 Newton. What is it? Resistive force. Resistive forces. What about resistive forces? 2000 Newton in the opposite direction plus 5000 Newton. So how about resistive force is 5000 Newton in the opposite direction. Now, according to Newton's first law of motion, resultant force would be 0. 0 equals to 5000 Newton in here minus, again, we can put this 5000, okay, 5000 Newton. So, 0 force, resultant force is what? 0. Now, show these mathematical assumptions as well as draw the diagram and everything. You got like very clear idea about now basic theory of Newton's first law of motion. Now we can happily do other questions. I'm not going to teach you Newton's second law of motion today. Let's do the equilibrium questions, considering all the time Newton's first law, Newton's first law, Newton's first law. Okay. So in the next week, at the beginning of the class, we are going to do Newton's first law, second law of motion, and what is called Newton's third law of motion. I want you to come up with some prerequisite knowledge. So watch these videos. If you can't find proper videos, ask me for me to send you the links. But you better try to find some videos and watch and come. It will really help you. So you have to search for force apply on pulley systems. Force apply on pulley system. So you have to search this in the YouTube and pulley systems, and put this in bracket when you search light pulleys, for light pulleys, because heavy pulleys, it is a different case. You have to wait for until what is called rotational motion lesson to learn about heavy pulleys. Now you have to search for light pulleys only. Okay. Light pulleys and heavy pulleys are two different things. Okay. It is like this. When you hang a mass from one side, like 2 kilograms, and here like 5 kilograms, the system will definitely accelerate towards here. You have to find out the value of acceleration. You have to find out tension. There are many more dynamic things to be done. In the next week, it will be more funnier than today. You might think, "Ammo, funny no. I told you, you can grab it in two different ways. If you challenge it, you will see many challenging things in the next week. So just try to find these things. It will be really horribly interesting. Okay, now we may be able to do, I think, inclined plane even in the next week. Okay, now we can go along with some more calculations. I will stop this recording part and record it as a new recording.